Welcome to section 1.4, angle measure. Again, I want to stress terminology and notation is extremely important, so make sure you're understanding how I am naming things. Okay, ray is a part of a line. It has one endpoint and extends infinitely in one direction. The way you name it is by stating the endpoint first and then another point on the ray. So here are two examples that you can call this ray. The endpoint is M, so you can call it ray MP, and you know that M is the endpoint and it goes out over P, or you can do the notation as just MP. Oftentimes you'll see me just write the endpoint and then a point on the ray, and I point into the direction that the ray goes in. You can't do it backwards, it always has to be the endpoint first. We can always call it ray MO or write it as MO with the arrow pointing in one direction. Opposite rays are two rays that have a common endpoint, and all points on the rays must be collinear. So it's basically you go in one direction infinitely and the other direction infinitely. And I'm just kind of redrawing the model that they have so I can talk and explain. So it starts at J, it goes out over K, starts at J, and it goes out over H. So these are two opposite rays. An angle is formed by two non-collinear rays that have a common endpoint. The rays are called sides of the angle and have a common endpoint, which is the vertex. Okay, so naming angles people seem to struggle with. You can name it one of two ways. If the vertex is not shared by another angle, you can just call it angle X. Use the symbol for angle. You can also call it angle, and you start on one of the side rays, come to the vertex, and to the other side ray. So it would be Y, X, Z, or the inverse, Z, X, Y. Z, X, Y. So the important letter here is the vertex, the vertex, the vertex. The vertex has to be in the center if you're using 3 points. An angle divides a plane into three distinct parts. You have an inside, an outside, and on it. So if you look at it, points Q, M, and N are on the angle. I could call this angle M, I could call this angle Q, M, N, and I could call this angle N, M, Q. Points R and S are in the interior because they're inside the, looks like it's an obtuse angle, which you should know, but they're inside the angle if we close the rays. And P and O are on the exterior of the angle, the exterior. All right, so what are all the ways to name angle 6? And number 2, name all the angles with the vertex at D. So I'd like you to pause the video and then come back and check your answers. Again, this is a very key skill. So for number 1, all the other ways to name angle 6. Angle 6 has this side ray and this side ray that make it up. So you can do you can do FBD, FBD, or you can do EBD, EBD. You can also do the inverses of that, so DBE and DFB. Those are the 4 combos. Angle 6, number 2, name all the angles with vertex at D. So the vertex at D goes right here. So we've got GDE, so GDE and the inverse, EDG. And then you can also do BDE, BDE, and EDB is the inverse. You've also got this angle here, angle 3 and angle 4. You can name angles with numbers. And they don't have this one with information to name it, but this is another angle with vertex D. So we have all those options. Notice we can't just use a single letter because too many angles share the same vertex. These are all types of angles which I'm hoping that you're acquainted with. I'm not going to spend a lot of time on this. Acute angle is an angle whose measure is greater than 0 or less than 90. An obtuse angle is an angle whose measure is greater than 90 or less than 180. And right angles is an angle whose measure is 90. And A straight angle is made up of opposite rays, and a straight angle is an angle whose measure is 180 degrees. It's a straight line, and these are all in degrees, so I should put my proper notation. Bang. An angle bisector is a ray, line, or segment that divides the angle into two congruent angles. So here we have angle XYZ. YW is the bisector. Therefore, these two angles are congruent, and you can see they have the same measure. Okay, so in the following figure, KJ and KM are opposite rays. KN is an angle bisector, and it's bisecting JKL. So I know that these two angles here are congruent if KN is the bisector. So JKN has an expression of 8x minus 13, and NKL has an expression of 6x plus 11. So because these two angles are congruent, then the expressions can be set equal to each other to solve for the variable. 6x plus 11 equals 8x minus 13. I subtract my 6x, subtract my 6x, and I'm actually going to do this in the same step. Cancels. 24 equals 2x. X equals 12. So now that I know the value of x, I'm going to substitute it into the two expressions. Oops. 6 times 12 plus 11. 72 plus 11. We're going to get 83. 8 times 12 minus 13, 96 minus 13, we get 83. They want us to find the measure of JKN, and the measure of JKN is 83. We also proved that these two angles are congruent by doing a check step. So my answer is angle JKN, the measure of, you put an M in front for that, equals 83 degrees. Okay, so now I want you guys to do this in your notes. Name all the angles that have B as a vertex. Name the sides of angle 3. What is another name for that angle? And name a point in the interior of angle DBK. So pause the video and give that a try. And I'll do one of these with you, and I'll let you try one on your own. So for number 1, PQT is 60 degrees, and POS is 4x plus 14. All right, what else are they giving me? QP and QR are opposite rays, and QS bisects PQT. So that must mean that these two angles are congruent. If they're congruent, then I can set them equal to each other. We're asked to find the variable value for x, 14, equals 60. I'll subtract 14, 4x equals, I'm getting tired, 46. Divide by 4, divide by 4, divide by 4. So x is going to equal 11 2/4, or 11 1/2. So now let's just do our check step. We're going to have 4 times, well, let's do it as a decimal, 11.5 plus 14. 4 times 11.5 will be 46 plus 14. 14 plus 46 will give me 60, and so it works. So the answer is x equals 11 1/2. So you guys are going to do number 2, and you're also going to make sure you did the answers on the last slide, and I will see you soon.